Switched on my radio, I heard nothing but noise. Spent all this money on all these toys. My tower is high, so my signal you should not lose. But when the numbers are low, I get the...
Hi, I'm Jim, W6LG, your YouTube Elmer, here in Rockland, California. Welcome to my radio room. I had a interesting contact with a guy in South Africa, and what made it really interesting is he was on the long path, so I was pointed west, going around the planet to him instead of short path, and he was very strong. He was well over S9. Subsequent to that, we had a couple of conversations on Skype, and I learned that he has what amounts to a unique way of feeding his beam antenna, his Yagi. And so I asked him if he would share that with me during an interview, and he's agreed to do it. And he's a really busy guy. He's a managing director of a company in South Africa. But he took time out to explain it, and I was able to get some pictures from him. So as you watch this interview, the last part of it where we discuss Feedlines really is a significant part of the interview, and where there's a lot of good information. So here we go. If you have not subscribed, please do that. I'm trying to build a subscriber base. And to help do that, I've invested in new cameras, new camera systems, and some other things to facilitate the recording of videos to make it a little bit faster for me to get them out. So here we go. Here's Shawn, ZS1SBW. Good. Hey, Shawn, how long have you been a ham radio operator?
I'm into my fourth year. I was licensed, 30th of October 2017, and I went on air the 3rd of December 2017. So this is the fourth year.
And when you first went on the air, what was your station? What did you have for equipment?
Well, when I became licensed, I immediately arranged to have a tower put in, a commercial tower. And I started with an N-fed halfway, so fed with RG213.
When you looked at the N-fed antenna fed with the RG213, you're feeding it at the high voltage places as opposed to the high current location, or where the current would be the greatest. Did you feel like that antenna performed well for you? And if so, what did you do to make it work right? To make that N-fed work? A lot of guys have N-feds, halfways.
I was flying the N-fed up at the top of the mast and over to my oak tree, and it performed reasonably well. I actually thought it's quite a good antenna for the really basic design. It's really, isn't it, that it's a Tesla coil, with a piece of wire on the end. It's an auto transformer.
Yeah.
So that's what it is, and it radiates very well, but it hasn't got good ears. And if you have a low noise floor, then they're great. But in an urban area, they don't hear that well, but they do get out.
Now, you fed it with RG213. Did you have some kind of matching network at the feed point to transform the impedance from 50 ohms to 5,000 ohms or so?
I did make an ugly bowline at the feed point, and I also engaged the owner, and he said I shouldn't use one, but I did use it. I don't know if it really made a difference.
The feed point of the N-fed long wire, about how far off the ground was it? How far?
Well, it was 65 foot at the top of the tower.
Okay, so the feed point to the half wave was at 65 feet or 20 meters or so, and then it went out horizontally from there, or how did you, to a tree?
Straight down the tower. Straight down. Oh yes, okay. So it went straight from the tower to my oak tree, which is across my property, to the front of my property. I have an oak tree, and I had a wooden wooden pole up, sticking up above the oak tree, and another insulator, porcelain insulator, and that was just drew it straight over from the tower.
Okay, so
it was horizontal above the house. So I'm about I would have to tell you in miles, I think, something. I'm about 7 miles away from the Atlantic Ocean, and about 7 miles, give or take, maybe half a mile from the Southern Ocean is where the two oceans come together. This is the most southern westerly tip of Africa. And I'm about 290 meters off the Indian Ocean. So I have water on the long path side to North America. I have water on the short path side. And then towards Antarctica, I have the two oceans combining into the Southern Ocean. And there's no land except for Bouvet Island and some islands between us and Antarctica. So you've effectively just got water. And this peninsula that I'm on is floating. And the groundwater is at about 1 to 1.5 meters below the property. So it's just water.
So when you went to put up the tower, you've got groundwater down a meter or so.
Yes.
What do you do to get the tower into the ground and stable?
That was also also another challenge because I had to, because it's sea sand, almost it's a sand dune. So I had to use a permabond. I don't know if you know the permabond, if you're familiar with this product. It's like a wood glue, similar to a wood glue, and it's used in cement. And when we dug the hole, we had to permabond the walls to stop it from falling in. I put 16 tons of concrete in the ground for the footing. It's a freestanding tower.
And when and how long does it take to cure concrete when it's in that kind of wet environment for so long?
Well, I left it
months or weeks or what?
No, just weeks, weeks, and then it didn't take long to cure it all.
I brought up QRZ.com while you were talking. What I was going to do was to see if I could get an aerial photo. I'll do that later. For those who are watching, if you have the opportunity to go to QRZ.com and look up ZS1SBW, there's some really neat graphics on there. The astronaut one is breathtaking. It's so well done. Anyway, that's a segue. So you got the tower up. The tower is 20 meters tall or so.
65 foot, yeah.
Yep.
So it's just under 20 meters, yeah.
And so what did you decide from there? What was the next part of the construction process to get the antenna on the top, rotator? What did you end up doing? What did you buy?
So I bought a Create rotator. So the rotator was a Create, and it was a fantastic antenna. It's the classic feed, which is capacitively coupled into the driven element. The driven element is longer than the reflector and the director, and that's because of the capacitive coupling. Very clever design, and I modified that and made it a 4-element. So it evolved. I was changing antennas a lot. So to more or less changing them almost as quick as I was putting them up, just because it's really fun.
For those,
I enjoy it.
For those that haven't seen it, in the middle of the driven element is a plastic cylinder with an end connector. And that end connector is connected to two pieces of what looks like the
RG213 sleeve
with the shield off, and you shove it into the tube. And as you're putting it together, there's no mechanical connection between the coax and the element. And you kind of wonder, is this going to work? And then when you get through assembling the antenna, you step back and you look at it, you realize that the driven element is the longest element because it's got this, as you said, capacitive coupling. So in essence, it shortens it up just a bit. And so you added another element to it?
I turned it into a 4-element. So I bought some hardware from Mousley and added another element to it. I modeled it in EZNEC, and I used some of the data from Mousley, and I came up with a 4-element. And it didn't perform much better than the 3-element. I think the 3-element was the difference, but maybe it was a difference from going from the end fed to the first beam, it was just dramatic.
Did you lengthen the boom when you added the extra element?
Yes, I did. Well, not the first time, but the second iteration I did, yes.
Okay. So is that what you have up now or no?
No, that's not what I have up now.
Okay, what do you have?
I have many versions. If you go to the bottom of my QRZ page, you'll see all the different kind of iterations. So I had the 4-element 20-meter up, and I always struggled with 40 meters. I call it the elusive band. It's a difficult band.
Yeah.
So you want an antenna that works, from 40 to, let's say, 10 meters, and 20 was the DX band that I really enjoyed, and I got my DXCC. My first 100 with my on 20 meters with the monobander, so I was very happy with that, and I got that in 8 months from starting out. So I was really chuffed with that achievement from this location. And then I was always struggling with 40. I was trying to get the end-fed half wave. I was trying to do the job with the end-fed half wave, and I never did. So I bought the urban beam from StepIR, and I tried that out. I stuck it above the monobander, and it didn't perform the way I wanted it to perform. So I bought some more hardware from StepIR and then modified it. And I ended up with, this is the third iteration of a homebrew StepIR, which performs very similar to their 4-element beam. So the specs are about the same in terms of the front to back. It's quite even across. The boom length is longer. It's 12 meters on the boom length, so it's a little bit longer than their boom. And the 30 meter element is a wide loop, where they have a kind of a butterfly loop. So if you look on my QRZ page, so it's a wider loop, and it really performs well on 40 meters. And we have SSB privileges on 30 meters, and I've tested it with some of my friends across the country on 30 meters. Performs extremely well. And I'm very happy with the antenna. I don't think I will change it now. I will just keep maintaining it and keeping it up there. I have to take it down at least once a year because of the highly corrosive environment, because I get out with it.
There's a guy with a harness and a gin pole, and he's working on the antenna. Who is that guy on the tower?
That's me.
And it looks like it would be a really windy location. Is that fair?
Yeah, it's very windy.
Yeah. And let's talk a little bit about, one of the reasons I made contact with you was I heard you on the air, and you were talking to a friend of yours, and I was pointed more towards Europe. I was pointed towards Europe, I should say, and not towards Africa long path. Africa long path would be about 250, 260 degrees from my beam heading. So you are off the back corner of my antenna, and yet I could hear you clearly. And I knew what time of day it was, and I thought, my God, he must be long path. But I hadn't heard long path in many months, a couple of years. So I turned the antenna around, and there you were S9 plus. And I was shocked by your signal, the strength of the signal. So the question comes up, it isn't just that antenna that's making that difference. And so tell me about the complete antenna system. And I noted in the pictures that you've got some gigantic, looks like a Helix coax. What was your thinking on that? Why the gigantic coax? Clearly, you're running what, 600, 700, 800 watts, something like that. So you don't need that kind of coax for that kind of power. What's going on there?
So obviously, I'm in an urban area, and one of I have a limited station, so I can have one tower and one antenna, and my YL Diane doesn't like wires, so I don't really have wire antennas around, but she likes the beam and I have to make it work with one antenna. And I spoke to a few people about Feedlines, and I'd actually come across your video in that process on coax and on Feedline losses, and I found this hard line. It's a Swiss one. It's Succo Feed. Huber Schuner makes it, and I gave it a try. You don't know how it works until you actually put it in. So I bought it. I had to order had to specially order the connectors and have them made. Minimum order quantity 10. one of the things that shocked me the most when I put it in was how quiet it is, because it has 120 dB. The shielding effectiveness is 120
Okay,
dB.
let's just investigate that just a little bit. If I were to buy RG8X, which has 94% shield or less sometimes, how many dB down would that shielding be? What's the difference between that and the coax that's used in terms of its ability to shield, or maybe related to RG213 or some other coax? Because minus 120 dB, we need to figure out where that lies in the scheme of things. Is that really good?
Yeah, so I would have to look at those numbers, but LMR 600, which is a really good Feedline,
Yeah.
or very good coax, is 90 dB. So just in comparison,
So
120.
okay,
Yeah,
so you're saying there's 30 dB of difference between the two
yeah,
coaxes? Okay, so
between LMR 600 and I'd say that's pretty much as good as you can get on a coax that's flexible.
yeah, so 30 dB is a 1 and 3 zeros. So 30 dB, one coax is 1,000 times better at shielding noise than the other. That's
Yeah,
that's hard to it's hard to even believe it's true. I mean, I believe you, but that's an amazing value for the coax. So its ability to shield noise is absolutely amazing, as is its
yeah,
price, I'm sure. Uh,
yes.
Go ahead.
So that was the biggest surprise. And I mean, the current length of Feedline, then the loss is about 0.03 dB for the Hubashuna, for the hardline,
That's
say,
at
and
what frequency is it? Are
uh,
you talking about 80 meters or
no, at 6 meters. So
at 6 meters? It's
for 6 meters,
it's
yeah,
0.03 dB, which means when you get to
dB.
20 meters, you couldn't even measure it.
Yeah, you couldn't. Yeah, it's not measurable.
And is there any loss in the connectors? Now looking at them, they look
Well,
gigantic.
the pigtails is that's the problem, because the pigtail has more loss than the entire hardline.
The
And
pigtail is
so
how
when
long? The pigtail is how long?
well, in total, it's 4 meters, 3 meters, 3.5 meters up on the loop at the tower, and half a meter from the linear to the hardline in terms of
So
coupling. So,
you're saying a 4 foot length of LMR 600 has more loss than your roughly 100 feet of the Huber Schuber super duper.
Ubashuna, yeah,
Yeah.
absolutely. And if you don't use LMR 600, it gets worse, So, and that, I think that was the most difficult thing to find. And the connectors for LMR 600 are very difficult to get, and they're not
They
easy
are.
to
Yeah.
get the connectors.
Yeah.
I didn't know that when I selected the coax. I should have selected LMR
Yeah.
400
The OD
in the
is
end, because it's so much easier. Yeah.
end connectors are easy. I don't know if you can get UHF connectors, but end connectors can be gotten for that. But they're very expensive because they don't produce them
Yes.
in the quantity that they do, let's say, a standard PL259 for RG213, which they make by the millions. The ones for LMR 600, which is manufactured by just one company. In fact, there are copies of it. There are other companies that make similar coax, but the real LMR
Mm.
400 comes from just Times Microwave, just one source. So I'm staggered because the loss in 4 feet of coax is greater than the loss of 100 feet of
Yes.
your other coax. So
Yeah.
you really decided that the most important part of the antenna system was the feed line. Is that fair?
Yes,
Okay.
absolutely, yeah, absolutely. Besides having the luxury of being able to work across the bands with a dynamic antenna, the most important thing is the feed line.
And why is that the case? Why is it with a dynamic antenna that can change length and frequency and its resonant frequency, why does that become more critical with a feed line? Why does that vary? Um, why is it different? Why is it different from a standard?
Well, I think it's the, let's say, the convenience of having an antenna that can work all of those bands, and they can function across those bands on a single tower with a single feed line, in a single station. And I think it's with our traditional wire antennas and maybe some other feed lines for those other antennas, and all the network that would go with that. Just having a simple station, which is not complex at all, having a good solid feed line that's quiet, because I'm in an urban, I have all this environmental noise around me. We still have these old three-phase overhead lines, which supply power, and they arc, and
Yeah.
all of this, everybody's experiencing this today. It's one of the biggest challenges in amateur radio, besides retaining our privileges and keeping our band space, our band allocations, but working within this environment that we have. And so the feed line makes a big difference. It shields the noise that would normally, be coupled. Also, there's another aspect to it. You will see the feed line is flying on the tower. It's isolated from the tower. It's if you have a look
let's
at the
see. Let's see.
yeah, if you have a look, there should be a photo that shows
Now,
you.
why did you do that? Why is it?
So it's not capacitively coupled to the metal of the tower. It's on standoffs away from the tower. It's not grounded to the tower. It grounds to an RF earth, which couples to the main house earth at the linear.
That's probably the
And
most difficult thing for any of us to understand is bonding, grounding, and earthing. So
yeah,
you did not. So the coax runs um, to the house. There's no connection between the shield and the tower,
nothing.
uh, uh, just to the antenna, which is isolated because it is that motorized driven
Yeah,
element. Then
yes.
when you get to the wall of the outside of your house, there you take it to ground. You've run it to a ground rod,
It
or what?
it runs straight in. So it terminates on the bowline inside the driven element. It flies down the tower, electrically isolated and capacitively, non-coupled to the tower, and then it comes through into the house, and it runs down the wall on those standoffs you can see in the photo, and then it comes to the linear. It couples to the linear, and the linear earths to an earth system, so it's earthed at the linear at that point. There is no other earth on the feed line at all.
Do you
So
know
there's
of
no loops, no earth loops.
one of the things I'm thinking about? It's a beautiful tower. That one of the things I was thinking about. Do you know of anybody else on the planet who did the kinds of things that you did? The very large coax. It's isolated from the tower, so it's far enough away where it's not capacitively coupled to the tower, which I think would induce some noise. And
It
and you
does.
kept it isolated, which is really contrary to what most guys would do at the tower. So that feed line runs isolated until it gets into the radio room, and then you convert and connect to some kind of grounding system.
So no, I don't know of any other installation that's been done that way. Obviously, once the elements are retracted, there's no electrical conductors up on the mast. It's inert, and the tower is grounded. So I have a UFA ground, and I have copper rods underneath as we say, copper rods underneath
Yeah.
the concrete slab.
The story behind that is when I was a building inspector for the first, I don't know, a few years, I thought it was an acronym for underfoot electrical something, and no, it's a guy's name, like
Yes.
Frederick Ufer or whatever, Jonathan
UFA,
Ufer.
yeah.
Or whatever.
Yeah,
Yeah, yeah.
yeah.
Well, I can tell you that uh, it's a remarkably strong signal coming out of South Africa, and to hear you on the long path, the guy you were talking to your friend is on the East Coast in Florida. And what was interesting about him is I heard him on, he's a very nice guy, and I had, do I break in or not? And then I moved the antenna around. I could still hear your friend on the East Coast, but then I detected an echo. So I was hearing your friend off the back of my antenna, and I was hearing him come around the planet. Well, he's got like 3 or 4 Yagis phased and all kinds of things going on, and he's in a good location. And it was amazing. And you guys did let me break in, and it was great fun. I had not been on Long Path in a very long time, years. When I grew up in Burbank, there was a hill behind the house, and all I had was
Yeah.
long path. There was no short path. If I turned the antenna short path to hear somebody short path, we didn't have a cluster then, of course. Guys in the valley were saying your S9, I could just barely hear them. And what I did was, as a kid, I went up this hillside, which was really steep, and I put in 4x4 wood posts, and then I made my own ladder line with insulators, and I went up to a Yagi that I put on a 16-foot tower, and I put it on city property, and it stood there for years, and nobody ever complained at the city. They went down and looked at it a couple times, but never said anything. So all I had was long path, which is a very interesting way to work, guys, and it can be lots of fun. So getting back to your signal, it was truly remarkable, and you heard me too. So that was you not only got out well, which is one thing, but you hear really well too. But I think the takeaway from um, your station is invest in good feed line, because if you have lossy feed line, you point out that you're going to allow noise, which is what we're all fighting, is this noise floor. The noise floor is S9, you're not going to hear most of the DX. So
Absolutely.
good coax really counts. Um,
Yeah.
and you like the dynamic kind of antenna. The antenna that I put up is just what you said. When I moved here, I put up a monobander for 20, and because that's the band I knew was going to be most active and have the most DX. Shawn, thanks for your time. It's fascinating
Yeah.
to see what it's like, and uh, the propagation that you have to different parts of the world is better than many, because you've got water shot across water in many different directions and peak directions. And I, again, I think the most important thing of what you discussed is that feed line. Get the best feed line you can get, and not having it grounded at the tower is fascinating stuff. I'll have to investigate that. Shawn, thanks a lot. I appreciate it.
Thank you, Jim.
Thank you. And I'm going to
73.
73, sir.